An ordinary plane, but on an extraordinary mission. Because Novaspace's latest Airbus A310 0G aircraft is being used by the European Space Agency for research into conditions of microgravity, which is why all the passengers are scientists. To obtain 0G, the plane must perform a series of parabolas. Before each parabola, on the pull-up, people experience almost 2G, so their bodies will feel twice their normal weight. The pilot calls out the increasing angle, and when it reaches a specific point, they inject the plane into the parabola. Everyone on board is then in microgravity as the plane free falls up and over the top of the curve.
It's now called out the angle, it's 40 degrees at 50. Injection, that is weightlessness. Here I go. The scientists have 20 seconds of weightlessness to do their experiments behind me. But there will be 30 of these parabolas, so they have plenty of time, 10 minutes in fact,
20,
to do
30.
their experiments. Time to get down now, because there will be a nasty thud. There we go.
There are 12 experiments on board, including 6 by students as part of ESA's Flying Thesis programme. The experiments cover everything from fundamental physics and neuroscience to psychology, looking at body image and perception. This experiment is examining the effect of microgravity on the brain. This is important for astronauts doing long-duration stays on the ISS, but there are also wider applications.
We are also interested in people with diseases, for example, Alzheimer's disease or dementia. If we know the mechanisms which are linked of a reduction of cognitive performance and brain activity and where that comes from, we might be able to better design strategies to then help these people.
Inside here is a pulsating heat pipe, potentially a new way of managing the thermal conditions of satellites or components on board the ISS. The copper pipe, seen here showing the flow of a condensed vapour, also has a section made of sapphire that is transparent to visible and infrared radiation.
In this experiment, we are using the infrared camera of the European Space Agency. It's a new camera, high-speed infrared camera, that will be used also on the International Space Station for the next experiments.
After each parabola, there is another 20 seconds of 2G as the plane pulls out to level flight. A few minutes later and the next parabola begins. In between each one, scientists must quickly reset their experiments and prepare for the next bout of microgravity.
This is the only microgravity platform where the scientists get to interact with their own experiment while it is in zero gravity. Rather than doing it by remote on a robotic capsule or sounding rocket, or on the ISS, it's humans, of course, but then it's astronauts doing it, and they can't possibly be as in tune with the scientific needs as the scientists themselves. So this is the only platform that really allows that kind of access, and as such, it's unique.
In the final few parabolas, everyone works hard to finish their science. For the German Mars Society experiment, however, there's only one shot to get this right, as it involves testing the initial deployment of a densely packed balloon that they hope one day will carry instruments for studying Mars's atmosphere. Whether it's preparing for Mars or helping life on board the space station and on Earth, the zero-G plane offers a unique environment for research and the closest conditions possible to simulate being in space.